the usage and the experiment of hydrogen will be very dangerous, then the alternative sources will be modeling simulation and maybe machine learning prediction. So it is safer and just need to build a robust simulator and predictor. So in this work, we'll examine or use the machine learning random forest technique to predict the hydrogen leakage in air. But because of the lack of information and data, we will create our artificial data set using a validated numerical model, validated against some experimental available data. So we can generate different scenarios, then trusted result, of course. Then we can feed it to the machine learning simulator to get our results. Before doing this, I will quickly go over the traditional model. Traditional, I mean the group of differential equations that govern the hydrogen leakage in air. This is the schematic diagram of the problem. So if we have an event here, as I mentioned, and we suppose that for some reason hydrogen escaped to air, to the ambient area, it most probably create a jet like this. If we get back to this, you can see the fire here from the source or from this car. It's a kind of jet. So I will not talk about the case of explosion, but I will talk about the case of fire, which is a kind of fire jet. So this is the model. Our model is a kind of semi-empirical model. And here we created the integral equations. We solve it numerically. And before solving it, of course, we need to validate our model against some experimental data, which is well done here, as you can see from this figure. So let's go now to the machine learning model. Let's define what is, in general, machine learning technique. So it's a kind of numerical simulator or algorithms that allow computer to learn from data and predict some other scenarios. So we selected the random forest, which is an ensemble learning method with large group of decision trees work together as ensemble to solve problem, and each decision tree generates a class of prediction randomly, of course, and the class with highest votes will be taken for prediction. This is very brief about the method, because we are not doing a fundamental research in machine learning, we're just running it, and we need to measure our results by a number of metrics like mean absolute error, mean square error, root mean square root, and also one correlation, which is we selected R-square correlation. The data set from the numerical simulation by solving differential equation. Then we present pre-processing of the data set, including statistical information, as I will show you just after this slide, hyperparameters, which is useful in just reduce the overfitting. And we use the function of grid search CV from the scikit-learn library. All of them are available in the open source code. We use the Jupyter node. And to solve it, we split the data set into 80 to 20% and run the simulator. Here is some statistical information we presented for the data set. And here is the correlation values between the different features here. We have 5 physical parameters, and they are correlated as you can see here. And here is the importance of the feature presented in this table to show how much, where is the physical where is the most important physical parameters here. And here also the tuning of the hyperparameters as it shows its importance based on this marker. And here same are plotted, but we include also the accuracy. As you can see, we have high accuracy for most cases here from you can read from the 3D colors here. And finally, here we have the prediction, the scatter plot of the actual prediction against the predicted hydrogen concentration. As I mentioned, we predict the hydrogen distribution in the closed area. So it looks very fine results data, and here you can read the number. And to conclude, yes, we generate an artificial data fit using a validated numerical model, and we run the hypertuning parameter, and we investigate our data set by finding its importance, correlation, and so on. Then we run our random forest simulator and check the errors and the correlation, which shows perfect. So in the future work, we'll just use larger data set and different data set also by simulating different scenarios and try to including numerical simulation and machine learning prediction to have full scenarios of hydrogen leakage in air. Thank you very much.